Okay, so this is all about analysis. This is the easiest part and often the last question in the paper. So make sure when you're reading time, you have a look and you see, are you able to do the last question on the paper? Because you might struggle through other stuff, and this is actually the solids of a revolution or area bound by the curve. Okay, so this question here is find if the area enclosed between the line y equals e to the 3x, the x-axis, and the lines x equals 0 and x equals a, is a third e to the 6 minus 1. So this is asking you to find the area under that curve like that, okay, between a and 0. What it is it's getting you not to use your calculator, okay? So we want to set up, we're looking at the area would be between a and 0 of e to the 3x dx. Now that's pretty easy to find the integral because it's a linear. So 1 over 3 e to the 3x between a and 0. So I want to put in my a, and I'm going to put in my 0. Anything to the power of 0 is 1. So I'm sitting with a third e to the 3a minus 1. Okay? And they've told us that it's equal to a third e to the 6 minus 1. So clearly, what would a have to be? 3a is equal to 6. So a is equal to 2. Okay. So it is simple. And if you have a look at the past papers, they've all been fairly simple. Okay. Find the volume of the solid of revolution formed when the curve y equals e to the x is rotated about the x-axis from x equals 0 to x equals 2. Okay, so e to the x again. This can be any shape. Remember, volume of revolution is basically around the x-axis is simply the formula volume is pi r squared times by height. So pi times your y squared dx. Okay, y is e to the x. So what am I sitting with? Y is e to the x. So y squared is clearly e to the 2x. So my volume is equal to pi between 2 and 0 of e to the 2x dx. This is straightforward integral once again, and I can work out my solutions, okay? So I end up with pi over 2 e to the 4 minus 1, okay? So you really and truly, these are pretty easy, okay? This question here is similar. Find the value of a if the area bound by the curve is a half ln 5. So we want to have a look at what our integral would be there. It's quite simple. I can go with linear minus a half ln to the mod 9 minus 2x plus c. So now I want to set up my area under the curve. So that integral is going to be between a and 2. Okay, so now I want to sub in a and I want to sub in 2. So I've got 9 minus 2a minus the ln of 5, clearly. Just using your log laws, that would be the ln of 9 minus 2a over 5 is equal to 1 over 5, because that would be ln to the 5, ln 5 to the minus 1. And now you can say 9 minus 2 is equal to 1, so a is equal to 4. This requires a bit of algebra and a bit of log knowledge. Okay. Okay, so this question here is just also, I don't know, some type of question you could get asked. They give you y is 18 over x and the normal to the curve at P63. Okay, so that's the normal. So that's determine the coordinates of r. Okay, so the coordinates of r, I would find the equation of the normal, I would assume, and then I'm going to find the x-intercept. Okay, so to find the equation of my normal, I want to find the gradient of my tangent, and then flip it around. Okay, so at that point, so there we go, dy dx, and there is my gradient of my tangent. Add x equals 6, The gradient is minus a half. So what is the gradient of the normal? Is 2. So I'm going to find the equation. I'm going to go y minus 3 equals 2x minus 6. And so I get y equals 2x minus 9. Okay. I want to find out coordinates of r. So I'm looking for the x-intercept of this, which is clearly 9 over 2. And so my value for r is 9 over 2 naught. So the next question then says, show that the volume of the solid obtained when the shaded region PQRS is rotated through 360 degrees about the x-axis is 18 pi. Okay, so solid volume of a revolution is pi r squared dx. So my function is, let's just quickly go back, pi r squared, so pi y squared, so that's 18x to the minus 1. Okay, so 18 squared and x to the minus 2 dx. All right, so I could actually use my calculator there, and they would expect you, no, they want you to show that it's equal to 18 pi, so you can't. Okay, so you want to put in your upper boundary, your lower boundary, find that value, and you'll get your answer. So they are, if they don't ask you to show and they ask you to just find the volume, they expect you to use your calculator at this stage here. But if they've asked you to show that something's true, then you clearly can't use your calculator. Okay, they are not anti you using your calculator. So 90% of the time, and remember that 80% of statistics are made up on the spot, but 90% of the time, they actually might just ask you to find the solution and not ask you to show that. But show that means show it. Okay, so let's get to the last question of integration, all right? And that is to do with a little bit with Riemann sums and sort of what can they ask about it, all right? So if we take this one, Matan finds that the area enclosed by the curve y equals ax squared plus 1, and the x-axis between x equals 0 and x equals 4 using Riemann sums. He finds that if he uses n rectangles, an expression for the area simplifies to this. So A is 36. So they've given you the final result, and I'm asking you to get to that. That's the final result, guys. This is important, okay? Then it says find the area of 12 rectangles used. Okay, so 12 rectangles used means I want to just sub in 12. So that's quite easy. If I sub in 12, I'm going to get 40.11. All right. B then is this an under or over approximation of the true area? Now, the true area, when we talk about Riemann sum, is your limit to infinity. And your limit as n tends to infinity would mean that this becomes a 0 and that becomes a 0. So your area would be 36. So this number is bigger than this number, so therefore it's an over approximation. Okay, it's quite a clever way of asking this question. And it's a clever way of understanding if you understand Riemann sums. Right, then it says determine by any method the value of A. Okay, so we're actually looking for A. It turns out we actually do know the real area now because they've given us this, and the true area is 36. So I can actually set up my integral between 4 and 0 of the function ax squared plus 1, and I can make it equal to 36. And I can then solve. So I would find my integral and sub in, and I would get what A is equal to. Okay, so look out for something like this. There you don't have to do the full Riemann sum, but it does give you the area, which means now we can work out all answers. Okay, I hope these lectures helped you. It's a beautiful subject, and I hope you have got what you wanted out of that subject. We look forward to marking your papers at the end of the year. Good luck, everyone. Bye.